Okay, good morning everyone. In the last lecture, we have started the most important concept of operating system, that is the process management, where we have learned that what is a process and the definition of a process and the difference between the process and a program. A program is simply a passive entity, whereas a process is an active entity, and a program execution is known as a process. And we have learned some other basic concepts, that the process is represented in memory, and it consists of not only the program code but a stack, a heap, a data section, a text section is also associated with each and every process which is there in the memory for the task of execution. And the last topic in the previous lecture, we have discussed in detail various states of a process: the new state, the ready state, the running state, the terminated state, the waiting state, and I have just explained all the states and the entire procedure in detail with you people. So in today's lecture, we have to discuss term, that is process control block, and after that we will just talk about the operations on the processes, which deals with mainly the process creation and the deletion of the process. So I hope all these basic concepts related with the process are very much clear to you. We have discussed each and everything in detail, and the state diagram also I have explained each and every concept and in detail, in depth with you people. So moving on to the further next topic related with the process concept is process control block. So process control block contains the information associated with each process, and each process in the operating system is represented using a process control block, and process control block is also known as the task control block. So if I show you this particular diagram, so this is what a PCB is, or this is what a process control block is. So if my system is running currently, suppose 20 processes, so each and every process in the operating system will be represented by an individual process control block, which will contain this amount of information for each and every process. So the PCB contains the process state, the process unique ID, the program counter, the various registers, the memory information, and the list of the various files and the folders related with that process. So every process in the operating system is represented using process control block, and operating system identifies each of the process using its PCB. So the process state, as we have discussed in the last lecture, the process may be in any of the one state. So suppose we have 5 different processes, so maybe P1 to P4 are in the ready state, or P5 may be in the running state. So the PCB represents the state of that particular process, whereas the program counter indicates the address of the next instruction to be executed for this process. Suppose P5 has completed half of its instruction and then it is sent back to the RAM to the ready state, then the program counter will point to that particular address of the next instruction that will execute whenever P5 will get the CPU next time. Also, there are some other information related with the process, like the registers, the scheduling information, which we will discuss in the next lecture in very much detail. What is the CPU scheduling? Also, the details with the related with the memory and the accounting information, like how many processes are there, what is the account number, what is the time limit, and also the input output status information of each and every process is stored in the process control block. So जितने processes होंगे उतने ही process control block होंगे operating system के अंदर, and OS used to identify those processes with the help of these PCBs. So this is the structure of any process control block, which is also known as task control block. And every PCB contains the information associated with that particular process. Moving on to the topic of operations on processes. So processes in the most systems can execute concurrently. So if we talk about the modern operating systems, we have the concept of multi-programming, multitasking, where multiple programs or multiple processes are executed simultaneously. So they may be created and they may be deleted dynamically as according to the requirement. So each and every system must provide a mechanism for process creation and the process termination. So if we talk about the operations on the processes, so these two are the most important operations. First is to create a process and second is to delete or terminate a process. And if we talk about the Unix operating system, for process creation, we have a system call with the name fork. And if for the process termination, we have another system call with the name exit. Similarly, related to these terms, we have a create process and a delete process system call in Windows, but we can easily use and include these fork system call and exit system call in our program. So we always talk about the Unix operating system when we talk about these process creation and the deletion. So the very first important process operation is the process creation. So during the course of execution, a process may create several new processes, and the process which creates a new process is known as the parent process, and the new processes are known as the child processes, and parent process creates children processes, and which in turn can further create the other processes. And in this manner, we used to have a hierarchy of processes. We used to have a tree of processes. And generally, processes are identified and managed using a unique process identifier, which is known as the process ID. And this process ID provides a unique value for each process in the system. And this PID can be used as an index to access the various attributes of a process within the kernel. So operating system do not know how many processes are there. It just identifies each and every process by its process ID, which is stored in the process control block. So if there are currently 10 processes executing, then there will be 10 different process control block, and each process by which operating system can identify those processes and operating system manages those processes. So if I talk about the Linux operating system, so there is one process with the name init, and that init process always have a process ID 1, and that process serves as a root process for all other processes in the system. And when the system has booted, that init process, which is the parent process, that creates various other processes, and that forms a hierarchy or tree of the processes. So different operating systems have different processes. So if I talk about Unix or Linux, we have a process with the name init, which always has a process ID PID1, and that acts as root or the parent for all other processes in that particular system. And if we talk about the various properties or talk about the resource sharing, so in general, when a process creates a child process, the child may require various resources to complete its task. And there are two possibilities. A child may able to obtain its resources directly from the operating system, or it may obtain its various resources from its parent. So either the operating system provides all the resources directly to the child process, otherwise a child acquires the various resources which are required from its parent. Similarly, when a process creates a new process, there are two different possibilities of execution. So there is one possibility that both parent and the child will execute concurrently, And the second possibility is parent will wait until some or all of its children terminate, and after that the parent will start executing its own instructions. So it totally depends upon the operating system, on some other factors, that how the execution will occur. In most of the cases, both parent and the child execute simultaneously, concurrently, but in some cases, parent allows the child processes to execute first, and after their termination, the parent executes its instruction. And if we talk about the address space possibilities, again, there are two different possibilities. Basically, child process is a duplicate of the parent process. So each and everything will be same, the same program and the same data. But there is another possibility that the child process may have a new program loaded into it. So in most of the cases, basically they work exactly same, except their process IDs, each and everything is same, but the child process may have another program or another task depending upon the availability or requirement of the system. So if we talk about the process creation in the Unix operating system, we have a fork system call which is used to create a new process. So you all must be familiar with this fork system call now. In the laboratory, we have created child processes using fork system call, and another system call is EXEC, which is execute system call, which is generally called after the fork system call to replace the process memory space with a new program. So in the previous point, in the address space point, we just have learned that a child may have a new program loaded into it. So if we want to perform that particular task, the child process initiates this EXEC system call, and the memory space will be replaced with a new program. And this is the scenario. You all must be knowing the fork system call creates a child process, and parent is also already there. And child process may execute EXEC system call if required. And once the child completes all its instruction, all its tasks, it simply calls this exit system call, which is used to for the process termination. And after the child process calls this exit system call, it is going to report to its parent that basically here the child process is informing its parent that the child has created all its tasks, and now it is waiting for the deallocation from the resources or from the memory. So this is how the scenario works. And these are some of the examples of process creation where we can use the fork system call. So already in our lab, we have completed all this task where using get PID and using fork system call, we can create child processes and we can display the process IDs. And the most important thing here is each and everything is same, but the process IDs, the PIDs are always different for the parent and the child process. So this is these are some of the examples in the Unix or Linux environment, but hopefully we have done all the programs in our C language. So this is how the things will work. The second most important operation of this processes are the process termination. So the very first operation was process creation, to create a process using fork system call, and another most important operation on the processes are basically the termination of the process. Now again, here are two different possibilities. First is the normal termination of the process, where the process itself terminates, completed all the tasks, executed all the instructions. And the second possibility is that in between its execution, the parent process may terminate the execution of the child processes. So two different possibilities are there for process termination. A process may terminate itself after completing all its tasks, or it may be forced to terminate just because of any reason. So I'm going to discuss all these things. So a process terminates when it finishes executing its final statement, and then it ask the operating system to delete it by using the exit system call. So just like fork system call is used to create a process in Unix, the exit system call is used to terminate or delete a process in the Unix environment. And when a process complete its task and it is executing its last instruction, then it requests operating system to delete it, and in that particular time the process may return a status value to its parent process. तो जब भी हमारा चाइल्ड प्रोसेस अपना टास्क कंप्लीट कर लेगा, इट हैज टू इन्फॉर्म इट्स पेरेंट प्रोसेस दैट इट हैज कंप्लीटेड इट्स एग्जीक्यूशन एंड ऑल द रिसोर्सेज just like the memory, the CPU time, the input-output devices, the files are deallocated by the operating system once the process complete its task. And the second category is parent may terminate the execution of its children processes, and this is the basically abnormal situation where the process itself do not terminate, but it is forced to terminate. So there can be certain different reasons. As you can see, the first reason can be the child has exceeded its usage of the resources that it has been allocated. Second important reason can be the task assigned to its child is no longer required. And the third and the last reason may be if the parent itself is terminating, then the operating system do not allow a child to continue the execution if its parent terminates. So there are so many different reasons the child may have to terminate in between forcefully without its own wish. And some systems do not allow a child to exist if its parent has terminated. And if a process has terminated, then all its children must also be terminated. So this is also a very interesting concept. Most of the operating system will not allow any child process to execute if its parent has terminated. So this particular phenomena, the concept is known as cascading termination. So suppose there is a process having 4 different children. So if parent is terminating due to any reason, then all of its 4 children will not be allowed to complete or to proceed further. So this concept is known as cascading termination because they are connected with each other. Once the parent terminates, all its children also terminates, just because operating system is not going to allow to complete or to continue the execution for the child processes. Okay, so we have just discussed to create a process, we need a fork system call. So similarly, to delete or terminate a process, we use an exit system call. And exit system call closes all of the process file descriptors, deallocates its code, deallocates the data, deallocates the stack, and then it terminates the process. So as we all know, a process requires several resources to complete its task, and when the task is completed, we can deallocate or we can terminate any process using exit system call, and exit system call is going to deallocate all the resources allocated to that particular process, and then it is going to terminate the process. And last point is interesting again, whenever a child process terminates, it sends its parent a signal and waits for its termination code status to be accepted. तो जितनी बार भी किसी child process को terminate होना है, उसने अपनी task complete कर लिया, it sends its parent a signal. So it always has to inform its parent that it has completed its task, and after sending the signal, it waits for its termination code status to be accepted. Now, the parent accepts a child's termination code by executing another system call, which is wait system call. Now, fork system call is used to create a process. Exit system call is used to delete or terminate a process. Another interesting system call is the wait system call, which parent process will use to acknowledge or to confirm that there are processes which are terminated. So Here are two important interesting terms will be introduced. One is a zombie process and second is a orphan process. So just before moving on to that, let me show you one more thing. So this is how the exit system call works. So you can just see here also. In the Linux and Unix system, we can terminate a process by using the exit system call, and we have to pass a parameter inside the exit. And if we are going to pass this parameter status 1, so this is the normal termination of any process, and otherwise we used to have several other important parameters which can be there. So we are just talking about the exit system call, which is used to terminate a process. And yesterday with IT41 batch, we have also worked on this wait system call where we can decide the order of execution of any of the process. If we want to the child process to execute first always, then we can use wait system call. So this is how the scenario works. So what I was just discussing is for process termination, the exit system call is used, and exit system calls deallocates all the resources which have been provided to the process for its task, and during or after its completion, the child process always sends or inform its parent process regarding its termination, and it waits for its termination code status to be accepted. And how the child will know that the parent has accepted its termination? So this will happen with the help of wait system call. So whenever parent will use this wait system call, then child can be easily deallocated completely from the system. And again, there is an interesting concept of zombie process. So a process that is waiting for its parent to accept its return code is called a zombie process. तो भाई zombie process क्या चीज है? कोई भी process जो अपनी तरफ से terminate हो चुका है, अपने सारे टास्क को कंप्लीट कर चुका है, उसकी सारी इंस्ट्रक्शंस एग्जीक्यूट हो गई हैं, उसके बाद उसने अपने पेरेंट को इन्फॉर्म कर दिया कि वो टर्मिनेट हो चुका है, एंड नाउ दैट प्रोसेस इज वेटिंग फॉर इट्स पेरेंट प्रोसेस टू एक्सेप्ट इट्स रिटर्न कोड. दैट मींस वो वाला प्रोसेस वेट कर रहा है कि कब उसका पेरेंट प्रोसेस wait system call को call करेगा, so that it can be totally released out from the system. So this concept is known as the zombie process. So here we can also learn a little bit about zombie process. So whenever a process terminates, its resources are deallocated by the operating system. However, now this is very important, its entry in the process table must remain. टर्मिनेट होने के बाद सारे रिसोर्सेज डीएलोकेट हो जाएंगे, लेकिन स्टिल दैट पर्टिकुलर प्रोसेस एग्जिस्ट्स इन द प्रोसेस टेबल. कब तक रहेगा? until the parent calls the wait system call, because the process table contains the process exit status. बिकॉज जस्ट अपना प्रोसेस टर्मिनेट होने के बाद उसने एग्जिट सिस्टम कॉल को कॉल किया था, एंड नाउ जब तक पेरेंट वेट सिस्टम कॉल को कॉल नहीं करेगा तब तक वो ज़ॉम्बी प्रोसेस बना रहेगा. ज़ॉम्बी प्रोसेस मींस अपनी तरफ से वो प्रोसेस कंप्लीट हो चुका है, कंप्लीट होते ही उसने एग्जिट सिस्टम कॉल को कॉल किया, अपने पेरेंट को इन्फॉर्म किया. now the process is waiting for the parent to accept or to execute this wait system call, and once the wait system call will be executed by the parent, now that process will be completely out of the system. So a process that has terminated but whose parent has not yet called the wait system call is known as the zombie process. Very important concept, zombie process and orphan processes. And the last line is simply, once the parent calls the wait system call, the process identifier of the zombie process and its entry in the process table are released. Now the process is entirely out of the system, but just if the process is terminated, only the resources are deallocated, but there will be an entry in the process table, means that process still exists in the RAM and it is not completely out of the system. When it will be completely out of the system? When the parent process will execute a wait system call, और जब तक parent wait system call को execute नहीं कर रहा, that process will become a zombie process just after its termination. So I hope the concept is clear. And now here is another possibility. What will happen if a parent process dies or terminates before the completion of its children or the child. So let's see here. There are certain issues. What happens when the parent does not accept the return code? What will happen if the parent terminates before the child process? So in that particular case, we do not have to worry. There is one parent process, as I have just discussed, the init process in the case of Unix and Linux. So init will adopt that particular child process and will become the parent process for that process, and it is going to accept the return code. And another possibility is if the parent of that child is alive, but still it is not executing a wait system call. So in that particular case, what will happen? The child's return code will never be accepted, and child प्रोसेस क्या बना रहेगा, वो ज़ॉम्बी प्रोसेस ही बना रहेगा जब तक उसका पेरेंट वेट सिस्टम कॉल को एग्जीक्यूट नहीं करता. सो लास्ट लाइन इज अनदर इंपॉर्टेंट इंटरेस्टिंग कंसेप्ट. अ ज़ॉम्बी प्रोसेस doesn't have any code, any data or stack. Why? Because zombie process already terminate हो चुका है, उसके सारे resources deallocate हो चुके हैं. A zombie process do not have any code, any data or any stack, so it doesn't use any system resources, but still it exists in the system, it exists in the process table, and it will be released entirely when its parent is going to execute the wait system call. So this is the overall concept of zombie process. Moving further, so what exactly wait system call works? It causes a process to suspend until one of its children terminates. A successful call to wait returns the process ID of the child that terminated and places a status code into the status. And if a process executes a wait and has no children, then wait system call returns a negative value. So if a parent process executes a wait system call and it is not having any children, any child currently, that means there isn't any zombie process and no need to return anything, so it is going to return negative value. But if a process executes a wait system call and is having one or more children, which are definitely the zombie processes, the wait system call will return immediately with the status of one of the zombies, and that zombie process will be freed from the system. So this is how the wait system call works, and this is how the things work for the zombie process. So कोई भी process जो completely terminate हो चुका है, अपनी सारी instructions execute कर चुका है, execute करते ही वो exit system call की help से execute terminate होगा, और उसके बाद वो immediately अपने parent को inform करेगा, और जब तक उसका parent उसको accept नहीं करता, उसको वापस acknowledge नहीं करता through wait system call, that process will become the zombie process. Moving on to the last topic or the last concept, what is an orphan process? So भाई किसी भी child process का parent process अगर पहले terminate हो जाए उससे, that child process will become an orphan. And what if the parent dies before its child? The child becomes an orphan. Now there isn't any need to worry. There is always a parent process, a root process in the Unix and Linux environment, which is known as init process, having PID 1 always. So it is going to adopt that particular child and it will become the parent of that particular child, and the things will go smoothly after it accepted that process as its child process. And this is the scenario if we intentionally tries to delete that parent process before the child process. So this diagram represents each and everything. So if parent dies first or parent dies before the child process, the init process, which is the root process, will adopt this child and it will become the parent for this particular child, and the things will go smoothly. So this is all about the today's class, and we have discussed in detail all the concepts regarding the basics of